Good afternoon, guys.
Good afternoon, sir.
Good afternoon. Still, a lot of people need to join. Only 10 people joined. Okay, we will start the class. So, in your last class, just a recap. So, in your last class, we seen about the junction field effect transistor, Jfet. Okay, and so what is the difference we seen? So, BJT is a current control device, and FET is a voltage control device. And BJT, using the base current, I can able to control the collector current, but here based upon the gate voltage I will control the drain current. Okay, so that's why it is called as a voltage controlled device. And we see in the types, the classification. So FET having two classification, one is JFET and another is MOSFET. So now we are going to study about the, we already seen about the JFET having a two types. One is the P channel and another one is the N channel. So, and so these are the just so unique features of your FET over the BJT, and it is having very high impedance. Input impedance is very high, and we can able to use it as a switch in digital circuits. So wherever you are seeing an IC, so inside the FET will be there. So it may be either JFET or it may be a MOSFET. Okay, and so three terminals we've seen. So those terminals are drain, source, and gate. So gate is used to control the flow of electrons or holes. If it is a N channel, the flow of electrons will be controlled. If it is a P channel, the flow of holes will be controlled. And source is used to generate, so it will give a huge amount of charge carriers, and the drain will use to take away the charge carriers which is coming from the source. Okay, so and these are the symbols for the N channel and P channel. So you should draw the same exactly how it is look like. Arrow mark indicates whether it is a N type or N channel or P channel. So N channel means if you should look at the gate, the arrow mark is direction towards the transistor, and in a P channel it is away from the transistor. Okay, and so N channels having a huge majority of area will be covered by N type, and the few area which is diffused or embedded or fabricated inside of your the transistor. Okay, so that are commonly connected as a gate, and drain and source are connected in a same single channel. Okay, single silicon channel in there. So those will if I am giving a more positive towards the drain with respect to the source. So if I am giving more towards the positive towards the drain when compared to the source, so that it will attract the electrons, so the electron will move from down to up, so that the current flow will come from drain to source, up to down. Okay, so this is the basics. If I keep on increase, initially the gate is grounded, so on the time a huge number of current flow will occur. Okay, and if I increase the gain from 0 to 1, 1 to 2, 2 to 3, so slowly if you observe that characteristic, slowly it will increase. So that area is representing the ohmic region, and after that, while giving a more positive voltage to the N, and the P is already 0, N is more positive, so it will create a reverse bias junction across here and here when compared to here. So due to increasing that, the flow of electrons become a constant one, so that the current become constant. So after that it won't increase, so that voltage is called pinch off voltage, representing after crossing the pinch off voltage, the current become constant. Okay, and if you give an negative voltage to the grain, it become more reverse bias condition, so that the flow of electron will be reduced. So that if you look at the graph, uh, characteristics. Yeah. if you look at the graph, if I'm giving a 0 voltage, so initially VGS is 0, so slowly I'm increasing the voltage in x-axis so that I am drawing the current according to that. So it is increasing uh, linearly. After that particular condition, it crossed, it's become a constant one. Okay, so where it is crossing, that is nothing but your a pinch of voltage. Okay, so pinch of voltage will be vary with respect to the gate. So if it is gate is have, I mean gate I'm giving 0 in the sense the printf voltage is around 4. Okay, so at Vg is equal to 0, the Vp is become 4, but if I keep on change the Vgs, the pinch of voltage become reduced. So it is represented using this curve line, dotted lines. So for Vg is equal to -2, the pinch of voltage is around 1 to 2.8 something. Okay, so here representing, so if you keep on decreasing the gate to source voltage, the curve will be like this, and if you further decrease it to -5, there is no current flow, so the transistor won't do any action. So this is the characteristics. So this is drain characteristics they used to tell. So if you look at that, the VDS, drain to source, I am giving, and I'm observing the drain current. Okay, so it is also called as a drain characteristics. Doubts about this? And one more thing is, in the graph they are representing the breakdown. So once you're improving more voltage, surely the semiconductor will occurs the breakdown. So after that breakdown, so the voltage won't be changed, the current will be changed rapidly. So this is for n channel characteristics. So if I am keep on decreasing the gate to source voltage, the drain current is decreased. So it representing that based upon the gate to source voltage, I can able to control the drain current. Okay, so that's why it is called as a voltage control device, and this is a P channel. So if I want to decrease the current, in the sense I want to give the positive voltage, here I am giving a +1 so that the current is decreased to almost 18, and if I'm giving 0, the current is almost 35, and if I'm giving a +2 for VGS, the current is reduced to 5 or 6 something. If you look at this, the another characteristics is transfer characteristics. You can able to think why in transistor configuration they used to talk about the input characteristics and output characteristics. So input in the sense, I will keep the output as a constant and I will change the input voltage, I will observe the input current, and as well as in your output characteristics, I will change the I will keep the input current constant and I will change the output voltage and I will observe the output current. But here it is quite different. Okay, so let's see the transfer characteristics of your FET. Okay, so transfer characteristics representing the relationship between your the gate to source voltage and as well as the drain current. Why? Because here we are not going to talk about the gate current. So anywhere if you observe, we are not going to talk about the gate current. Only maximum the gate voltage we will talk about, and as well as the drain current. What is the drain current and what is your current flowing from drain to source? Okay, so this is a major parameters which we are going to discuss hereafter. Okay, and so that's why here they are concentrating on the gate voltage, not the gate current. So that's why it is representing the voltage control device. Okay, and so we are going to make a graph, so with respect to your the gate to source voltage and how much current will be controlled. Okay, so that's why it is representing the transfer characteristics. So it was introduced by the Shockley, he is a scientist. So it's become a Shockley equation. So he given a derived equation that in order to find the drain current, so id is equal to IDSS. So this is nothing but a drain to source current. Okay, so ID is nothing but a drain current and is equal to drain to source current. Okay, and within a bracket 1 minus VGS by VP the whole square. So VGS, gate to source voltage. So that is a control that will be vary with respect to, in a graph you can able to see it can able to vary, and um, the pinch of voltage will be constant for a gate voltage. So if you suppose the VG is equal to 0 means the pinch of voltage is constant for that, and as well as the drain current for that it will become a constant one. Okay, so these are the variables, control variables. VGS is a control variables, and the pinch of voltage and IDS should be will be a constant. So when, in the sense when the VG is equal to 0, so on the time what is your pinch of voltage? If you look at this graph, so VG is equal to 0, right? So there only I am considering the pinch of voltage at maximum. So this is constant one. Okay, for a FET transistor, so they will give you a maximum. So maximum in the sense what is the current, maximum current I'm achieving when the VG is equal to 0. So they are representing that one, and that is a constant one. Only thing is variable is VGS. So here they are representing. So when VG is equal to 0, ID is equal to IDSS. Okay, look at the graph. So when VG is equal to 0, so this is the portion. So when VG is equal to 0, so the drain current will be equal to your drain to source current. So what is the drain to source current? That will be equal to your ID. So look at this equation. If you put VG is equal to 0, so what will be your answer? Just put VG is equal to 0. What will be your what will be your ID? ID is equal to what?
No, sir.
Hmm?
0.
Just put VG is equal to 0 in this equation and check what is your ID. Put VG is equal to 0, ma. So this portion I am substituting 0, right?
Yes, yes, sir.
This will become 0. 0 divided by anything?
0.
0. It is equal to 0, right? So what will be the remaining portion? 1 square.
1.
So what is the 1 square?
1.
So 1 into IDSS. So that IDSS.
IDSS.
So ID is equal to IDSS. So that is what
IDSS.
here they are representing. So when VG is equal to 0, so ID become IDSS. Okay. Okay. So in this graph, they're representing the drain characteristics as well as your transfer characteristics. So this is nothing but your drain characteristics. I will write as DC. It's not direct current. Drain characteristics here. It is a transfer characteristics. Okay. If you look at this, this already we discussed. So let's go for the transfer characteristics. You know that VGS. I'm going to draw in x-axis VGS. Okay, if you look at this, this is a VGS and this is your VDS. So there will be a, so there will be a difference. So x-axis in this this is the VDS and this is a separate graph. Okay, I'm just keep it, I just kept nearby. So don't think it is the same axis. So this axis is different, this axis is different. Okay, but ID is same only. Here also y-axis is ID, here also y-axis is ID. But x-axis here it comes for VDC, sorry, drain to source voltage, and here it is gate to source voltage. Okay, so if the VG is equal to 0, you know that, look at this graph. So VG is equal to 0 means you know that you may get the maximum current. So that is your IDSS. Okay, and so if I keep on decreasing the gate to source voltage, what is happening? What is happening in drain current? What is happening in drain current?
Increase.
It is decreasing. So it is decreasing. See, at which is equal to 0, it is 8. If I am keeping which is equal to -1, and I'm getting around 4.5. So it is decreased off of the value. Further, if I'm decreasing the VGS, it's become one at what particular condition, I mean particular gate to source voltage, it becomes 0. Is it right or not?
Yes,
For
sir.
an example, just keep 0, you got 8, and -4, I got around 0.5. If I keep -5, surely it becomes to 0. Okay, so for an example I am talking, and similarly that is what I am going to draw in transfer characteristics. So transfer characteristics, I am going to draw the drain current with respect to your gate to source voltage. So at gate to source voltage is equal to 0, I got maximum current, and when I am keeping gate to source equal to -1, I got somewhat around this voltage. And when the gate to source voltage is equal to -2, I got the value of IDS is how much I got? 2, right? So I am drawing here at -2, I got the IDS equal to 2. And when the VGS equal to -3, so what is the maximum current? It is equal to 0.5. So that is what I am drawing here. So when the VG is equal to 0.3, the current is 0.5. So when is the VG is equal to -4? Oh, they are representing here in down. So that is totally 0. So at -4 it is become 0. So this is your transfer characteristics, which is drawing in negative, I mean negative axis. It's not a positive axis. So now you understood, right? So what is the drain characteristics? What is the transfer characteristics? So drain characteristics is going to draw the drain current along with your drain to source voltage, and similarly transfer characteristics, I'm going to draw the drain current along with your the gate to source voltage. So gate to source is input voltage, and this is your ID is nothing but output current. So these are different, so that's why transfer characteristics it is named as. If you look at here, so this is your the output voltage and as well as the output current. So both are similar. So and it is going it is observing for the drain only maximum. What is the drain voltage? What is the drain current? So it is named as a drain characteristics. So that's why it is named as drain characteristics, and this one is named as transfer characteristics. Any doubt in this graph? So next is some parameters we are going to see. So there are totally 4 parameters we are going to see. One is the drain resistance and transconductance, that is called a GM, and the output resistance, and as well as the amplification factor we are going to see. So drain resistance, come to the drain resistance. So this is going to calculate from the drain characteristics. So go to the drain characteristics. So I'm going to take any two voltage level which is available in VDS, and I'm going to observe what is the corresponding current. So for an example, I will take the value of these two. Okay, so two value I'm going to plot. This may be around 2, and this is your 5. Okay, and I'm going to observe what is the current here. So current is, so what will be the equation? It is around 5 minus 2, that is equal to 3 divided by, and here if you observe it is maximum value is 8 and the minimum value is 6.5, so 1.5 milliamps, so that I can able to find what is your drain resistance. Okay, so that is what representing here the drain resistance. It's the AC. So RD is equal to AC means I am taking a two variable, so it's not a static one, it's a dynamic one. So the AC is nothing but dynamic, it will keep on change. Static means it's a DC, so here they are representing in terms of AC. But in a transistor characteristics, we used to find the static resistance and dynamic resistance. So static resistance means only one point I will take. For an example, I will take only one point. So 5, and what is the current? 8 milliamps. So I will write the equation as R is equal to 5 divided by 8 milliamps. So this is for only one value. Okay, static resistance. At that voltage, what is the resistance I am finding? And the dynamic means while changing the voltage 2 to 5, what is the current I am observing? So that is your dynamic. So here they represent using the AC resistance. Okay, so it is defined as the ratio of infinite. Sorry. infinite decimal, actually it's a decimal, a change in VDS to the corresponding change in drain current at a constant value of your VGS. So I'm keeping a VGS as constant. If you look at this graph, I'm taking the value of VGS at 0. Okay, so it's a constant one. Only variable is the VDS value is variable and the ID value is variable. So if I want to calculate for VGS equal to 1, I will use this graph. I will plot where it is changing. I'm not going to calculate from this 2 point. Why? Because both are same. So only thing is wherever there is a change, there I will find the resistance. So that's why if you look at these characteristics, they used to represent it is a ohmic region. In the sense the resistance are changing in this condition. So I will plot the graph with where there is a change in a graph. Is that clear, ma? All of you? So how they are calculating the resistance? I'm not going to calculate at the constant value. I'm going to calculate the where there is a change. Okay. So the equation is del VDS by IDS. And let's go for the transconductance. So transconductance representing the relationship between your uh, drain current with respect to the gate to source voltage. So that will be derived from your the transfer characteristics. So if you look at the transfer characteristics in the x-axis, it is a VGS, and y-axis it is a ID. So I'm going to find the transconductance between two. So why I am telling transconductance means this is a output current and this is your input voltage. If you look at here, it is also output, it is also output. So I will tell a commonly resistance. Why? Because it is belongs to a same source. It is not about input and output source. It is a fully depend on your output source. Only it is deriving the output current with respect to your output voltage. But if you come to this characteristics, this is the input source and this is your output source. Which one? So input source is gate to source voltage and output source is your the drain current. So that's why they're representing using the term a transconductance. Okay. So if you look at this, GM is equal to so del ID by a del VGS. So this is the equation, and next is yeah. So input resistance. Mm, so most probably input resistance we are not going to calculate that much. And if you look at this input resistance, they are talking about the gate to source voltage with respect to the gate to source current. Okay, so the gate to source current is very minor one. Why? Because the voltage which we are going to give, that will be negative and the current flow is very less. Okay, so maximum if you have in your examination, they will ask mainly about the problem based upon your the drain resistance as well as the transconductance. Okay, and amplification factor one more is there. This is your drain resistance, already we've seen, and this is your transconductance. So that is by keeping VDS as a constant, I am going to calculate the transconductance with the ratio of your drain current with your IGS. And what is your amplification factor? So you know what is the amplification factor. So what is the amplification factor which we found in transistor, BJT transistor? What is amplification factor, ma? What is amplification factor? Alpha, beta, gamma, which we seen in BJT transistor.
Sir, alpha.
How you will calculate that amplification factor? Amplification factor is nothing but the gain. So gain can be calculated with respect to the output with respect to input, right?
Yes, sir.
Yeah, so output current, what is output current and what is the input current? So based upon that we derived. So here also we are going to find what is the output and with respect to your what is the input. Okay, and so output voltage is what is the output voltage actually in a FET? Output voltage.
Output voltage equal to input voltage.
Output voltage is equal to input voltage. Ratio of output voltage to input voltage. V naught by Vi. Okay. And what is the output voltage for a FET, field effect transistor? What is the output voltage? Okay, what is your input voltage then? Anyone? You guys are listening. What is your input voltage in a field effect transistor? Look at this graph. What is your output and which is output and which is input? Oh my God, guys, you
Sir,
people are listening
sir,
or
that
not?
increasing is output, sir.
Which one?
Increasing
Which one is the output
ID
voltage? See, totally three parameters are there. One is your VGS and one is your ID and another is VDS. My question
VDS.
is, which is output voltage and which is input voltage?
VGS.
VGS
Input,
is
sir.
input, correct. And
VDS is
VDS
output,
is the
sir.
output, correct, correct. So amplification factor can be calculated by the output voltage VDS by the input voltage VGS, right? So from this equation, the amplification factor here representing the mu. So mu is equal to, they representing the drain resistance. So drain resistance, what is drain resistance? Del VDS. Okay. So del VDS divided by and del IDS ID multiply by, so what is your transconductance GM? So GM is equal to del ID divided by del VGS. So this is your equation, right? So what will happen? The ID will get cancelled. So the mu become, so what is your final equation? So del VDS divided by del I, sorry, del VGS. Is it right? So now you got it right. So previously I told amplification factor is the output voltage divided by your input voltage. So that is what you got it here. So that they are represent using the drain resistance as well as the transconductor. Okay. And so dynamic resistance, what is the unit for resistor? Resistance unit, what is the unit for resistance, ma?
Sir,
Oh, yeah, correct.
ohm.
And so have you studied about transconductance? Do you have an idea about transconductance?
No idea, sir.
Any idea? Okay. So actually it is a quite opposite to your resistance. So 1 by R is equal to G. So inverse of your resistance, I mean the transconductance and resistance are inversely proportional to each other. Okay. So RD is nothing but inverse of your 1 by G. So here the unit will be a mho. Invert ohm is nothing but mho. Okay, so that is a unit for it. So the relation between the transconductance, I mean the resistance and the transconductance inversely proportional. Okay, so that's why it is represented using mho. So here this is ohm, quite opposite to each other. Okay. Okay, and here they represented, we know this equation, that id is equal to idss into 1 minus vgs by vp the whole square. So this is the equation, known equation, just a small exercise here. And this equation is derived from here. So how, in the sense, just take it id here, so if id is go to new denominator, so equation will become id divided by idss, right, is equal to, the remaining equation is 1 minus vgs divided by vp the whole square. Suppose if I take if I'm taking the square root on both sides, so that equation will become square root of id divided by idss, idss, and here it will become 1 minus vgs divided by vp. Okay, so if I want vgs and vp, so I will move this to here and I will move this to here. Is it right or not? I want to move, so that what will become, so vgs, if it comes to, I mean negative, so vgs by vp is in negative, if it is come to left hand side it become positive, so vgs divided by vp is equal to 1 minus, and the root of square root of id by idss, if it goes to right hand side it become negative, so I am writing it root of id divided by idss. Is that clear, guys? It's a simple operation. And after that, if I moved the vp to numerator, it will become vgs equal to vp will become multiplications to that equation which is available here. So I am rewriting this equation as vgs equal to vp into 1 minus root of id by idss. So from this equation only I am deriving this one. Okay, so just a small exercise here they are giving. So they are giving that idss is equal to 12 milliamps. So it representing that the IDS is equal to 12 milliamps, representing that when the VGS equal to 0, the maximum current they are representing. And as well as here they are representing that VGS off is equal to minus 6. So here it representing that it will become ID is equal to 0. We already see in transfer characteristics, right? So when VG is equal to 0, I got maximum current. So that I am representing here. IDS is equal to 12 milliamps, and as well as the VGF in bracket representing off. So off representing that there is no current and all. Okay, so at which voltage is occurring, in the sense minus 6 voltage. So like a transfer characteristics they are representing. Okay, so I'm going to derive, I mean I'm going to draw the transfer characteristics using these two value. How, in the sense, take a graph. Actually it is wait, I will remove everything. So take a graph which is available here. Now I know the 2 points. One is IDS is equal to 12 milliamps. So I am going to plot this as a 12 milliamps. So when VG is equal to 0. Okay, so that is what I am representing here. And as well as here they are giving VGS off is equal to minus 6. So it representing that at minus 6 when the VGS it becomes 0. So the graph will be somewhat like that. Is it right or not? So it will be like this. Now I need to find what is the mid value. So for that I will use this equation that will be substituted, and from this. Okay, so I will use this equation and I will transform it into this, and I will find what is your the in between value. Okay, So if you look at this, initially the VG is equal to 0 means it representing IDSS. So representing VG is equal to 0 means what will be your the maximum current. So what is your maximum current? That is nothing but your 12 milliamps. Is it right? And substitute that. Suppose if I'm giving IDSS by 2, so half of the value I'm giving. So ID is equal to IDSS by 2. Just anyone can you able to calculate this? Anyone can you able to calculate this? You don't have a calculator? All of you? Anyone?
No, sir. We are having in hostel.
Hostel. Oh my. Huh. Nowadays everyone using smartphone. Okay, leave it. So if you look at, I will. Okay. So by substituting the value, we can able to identify what is your VGS. Otherwise, by substituting this, I mean, for example, 0.5 VP. So VG is equal to 0.5 VP. If I'm substituting here, I will find what is your the ID value. So I can use any one of the equation. So thing is, I will assume that VGS value. For example, first I'm telling using this equation. Okay, I'm going to find out the ID by keeping a some voltage of your VGS. So what is your maximum VGS value? It is -6, right? So that is your okay. So I will keep the ID. I will keep it ID, and then I will calculate the VGS. Okay, from this equation. Suppose so initially IDSS I kept that is a maximum current of 12 milliamps. Okay, so ID is maximum value of 12 milliamps. So I'm going to calculate using the ID value. What is your VGS value using this equation? Okay, so look at this equation. So initially I kept ID is equal to IDSS. So substitute here ID is equal to IDSS. So what will happen? It will cancel each other, and you will get VGS equal to what you will get. What you will get, ma? So it is cancel each other. So 1 minus 1. What is the
One.
value? It is 0. So root of IDSS by IDSS is equal to 1, and here already 1 is there, minus another 1, so it becomes a 0
Zero.
multiplying your anything, it becomes 0. So that is what I am
Zero.
driving here. Okay, and next case I kept half of the value, so IDSS by 2. Now IDSS is 12 milliamps. I will substitute 6 milliamps to here. So in a numerator, it is in numerator it is 6 milliamps, and in denominator it is 12 milliamps. Okay, ID I am substituting IDSS by 2. It representing 6 milliamps. So ID is 6 milliamps. So in this equation, I will substitute like VP. So far I don't know. VP I am drawing into 1 minus a root of 6 divided by 12 milliamps. So milliamps get cancelled, and this it will become because 1 minus root of 1 by 2. So after that I got an answer like 0.3 VP. Okay, VP is I'm just keeping it as a, like an unknown value, and after I'm substituting that IDSS by 4. Okay, so if you substitute IDSS by 4, um, so you will get 3 by 12. Okay, so after substituting this you may get some equation, and if you simplify that you got the answer like 0.5 VP. Okay, once again if I'm substituting IDSS by 8 or a 10, after that I will go for the 12. So likewise I will keep on change the value. I will observe what is your VGS, and after that I will draw the value like this. Okay, so if you look at this, initially it is 12. Look at, so initially the value is 12, and I know this value is given, as well as they given at -6 it becomes 0. Okay, so now I need to find the in between any value. So if I plot any two value, I can able to draw a curve. So in order to identify that value, I'm just giving something. It's like this is 6, so this is IDSS by 2, and this equation is IDSS by 4. Okay, so for that value, what will be your the gate to source voltage? That is what I am going to observe here. Okay, so similarly, they given another one by giving some value. They are plotting that transfer characteristics. So this is for a P type. And if you look at this, how to identify the P type and N type means, and look at the question here, it is given positive. So positive representing the P channel Jfet. And if you look at the previous case, they're representing using minus negative value of VGS. So it representing your the N channel. So sometimes they won't mention whether it is a P channel or N channel. So you have to identify using the gate to source voltage. So gate to source voltage they given in positive or negative. Look at this and then identify whether it is a P channel or N channel. All of you clear, guys? Guys, any queries?
No, sir.
Still, how many topic is there for you left?